what is the basic idea of the chapter? What is that we are doing with it? How is that it going to be useful? It's useful in determining the number of different ways of selecting and or arranging objects without actually listing them. What does it mean? I have an example over here. So I have 4 objects. I have to list them in a particular order. I have to arrange them in a particular order. It could have been 4 people, 4 objects, 4 things. It could have been anything. 4 cities that I want to visit. So the question is, how all can I do it? Right? I'm selecting, actually not selecting, arranging. So if I run this, so this is the first possibility. This is your second possibility, right? So on and so forth. And that is your last possibility. Of course, this is just a list. It could have been in any order, right? So here I'm not doing any kind of selection. It's just directly arrangement. So if you have to select 2 out of all of this and arrange them, again we'll have a particular set of outputs, right? So the thing is, if you have to do this was just 4 things, and that to not selection, only arranging. And we have 1, 2, 3, 4, 5, 6, 24. We have 24 possibilities just with 4 objects, and that too with arranging, right? Think about so many different possibilities of things happening in the world, and if you have to list them, it's not practical, right? We just want to know the number of ways of doing it. Without listing it, we can use this chapter. If you want to list it, then you have to list it. There's no other way. You can use a particular Python code. You can use, of course, not only Python, any kind of programming language to list it out. So that is not a small thing or a big thing, but yeah, if you have to list something like 30,000 things, it's not practical. Anyways, the point is, if we have to, where is it? It's useful in determining the number of different ways of selecting or arranging objects without actually listing them, without actually writing them down. If you want to look at a number, okay, we're looking at so many possibilities without actually listing over here, right? I could have known there are 24 ways of arranging 4 objects. Okay, so where else can we use it other than this 4 objects? Arranging people for a photo shoot. So same example, there could have been 4 people. So these 4 people, how all can we make them sit? This is one of the possibilities, right? So one more example, it's a textbook example. Mohan has 3 pants, 2 shirts. How many different pairs of a pant and a shirt can he dress up with, right? Some as simple question as this. Or if you want complicated scenarios, here are a few of them. Circuit designing, production planning, networking, quality control, all of this engineering problems can be solved with permutation and combination. Gaming, so counting the number of possible game status, calculating the odds of success, counting the number of possible moves, estimating the number of players. So this is practically needed when we have to build a game. Again, we will never know just by arranging and thinking about it. The maths will tell us how many possibilities are there. It's quicker, right? It's quicker. So depending on that, then you will get to understand what is the CPU required, GPU required, so on and so forth. So all those numbers are important when you're talking about possibilities, when you're trying to understand how the game should be built. So before the game is built, there are a few mathematics that has to be dealt with, few technical aspects that has to be dealt with. For that, we need numbers, and that's where your permutation combination comes into picture. One more very important field of research, DNA sequencing, drug development, enzyme kinetics, ecological sampling. So point is, quite a few fields. Of course, I have not listed all of them. It's not practical again. So whoever is interested in whatever, you guys can pause, search about it, web search about it, try to learn about it, right? So nothing to write over here, just an introduction.